Hello everyone, I hope you all are doing good. By the way, welcome to my YouTube channel Physics in a Nutshell. And if you are just new to this channel, just subscribe it. And if you just like my way of teaching, hit the like button. Okay. By the way, this is the time we should start our class. Okay. We are basically discussing about the lesson gravitation. Till now, we have discussed almost this is our third lesson, right? First we discussed what? Motion. Then we discussed about forces and laws of motion. Then now we are discussing about the third lesson, that is your chapter 10, is that about what? Gravitation. In the first class, we have actually discussed why that term gravitation comes into act. Okay, why Newton had to introduce that new gravitation term to us right now. When Newton actually did that, when one apple just fall on him, right? Then Newton just introduced that term gravitation to us. Okay, then what we did, we actually discussed the gravitational force between every object. Then we moved towards our one main topic, that is nothing but what? Gravitational force between our Earth and what? Moon. Okay, how that moon and Earth is actually related with each other, or how they are attracted to each other with the help of that gravitational force, we also discuss, right? Then we actually move towards that universal law of gravitation. Then there we actually discuss one constant, that is not about what? UGC, not a university, that is universal gravitational constant, that is denominated by capital G. Right? And with the help of the certain quantity or certain experiment that was done by Henry Cavendish, okay, he used one very much sophisticated and sensitive instrument. With the help of, he calculated the value of G, which is nothing but what? 6.67 into 10 to the power minus of 11 Newton meter square per kg square, right? Then we discussed that free falling of an object under the gravitational acceleration or gravitational force, that then we actually get one more new term, that is known as what? Acceleration due to gravity, or known as gravitational acceleration. Okay, having a formula, small g is equal to what? Capital G into mass of r divided by radius of r square, that is g m by r square, right? By the way, sorry if you get some extra sounds, because in my home some extra work or constructions are going on. So if you get any kind of extra sounds are there, please, I'm just very much sorry for that. Okay, then we actually calculate the value of small g using the mass of Earth, radius of Earth, and then putting the value of capital G, we get the value as 9.8 meter per second square. Then I told you that in Earth's surface or near to Earth's surface, G remains constant, but at the pole and equator, it changes. Okay, at pole it is the highest compared to the what? At equator, it is going to be less at the equator. Now, today we have to actually discuss, considering that gravitational acceleration or acceleration due to gravity, we have to actually discuss the motion under the gravitational force. Okay, when we are actually discussing the lesson motion, that is our first one, that is chapter 8, we get the motion in a straight line or a circular path. Then we are discussing about the linear acceleration or the circular acceleration, right? We get a normal distance from one position to the other position, right? And we get the motion, then we get the speed. When we give a direction to that speed, it becomes velocity, right? When we just discuss that change of velocity with time, we get acceleration. Right now, here already we have that acceleration, known as what? Acceleration due to gravity or gravitational acceleration. Right now, today we have to basically discuss the motion under what? Gravitational force. See, whenever I leave something from this height, what is going to happen? It is going to get to the ground, right? So, but when it is at my hand, it is at rest. When I just leave that ball or an object, what is going to happen? It will attain a velocity. But the fact is, we have got that gravitational acceleration. Always remember one thing, you should have clear your concept about the velocity and acceleration. Many students ask me about the questions regarding velocity and acceleration, right? You have to be very much clear. If there is gravitational acceleration, but before that, okay, before that, when you leave something from certain height, from this height, what is going to happen? We say that it goes to the ground because there is certain force applied by the ground to that object. That force is nothing but what? Gravitational force. If there is gravitational force is there, that means what? There is going to be acceleration, because the definition of force or the formula of force is what? Mass into acceleration. That means what? There is going to be one acceleration that acting on the body. If there is acceleration, always remember, if there is acceleration, there is going to be the what? Change of velocity. If there is no change of velocity, you are not going to get what? Acceleration. If there is no acceleration, you are not going to get any kind of force that is acting by what? Earth on that body. Okay, so this is a concept you should be very much clear about. Okay, when we have to discuss that motion under the gravitational force, okay, with the help of that gravitational acceleration, but before that we have to clear our concept regarding one actually experiment. This experiment was done by Galileo Galilei. Okay, he was the scientist or the physicist before Newton. Okay, Newton was after him. Actually, Newton followed his idea of this gravitational force. How he actually discussed that? Do you know, have you ever heard about the Leaning Tower of Pisa, which is in Italy actually? Maybe Italy, because I don't know. If I'm wrong, just correct me, because I'm very much bad at geography or social science. Maybe it is in Italy, okay? So what actually Galileo did, he take two balls, okay? First he moved to the top floor of that Leaning Tower of Pisa. Then he take two balls, okay? He then leave the two balls at the same time, okay? But where he observed that two ball is going to reach the ground, okay, at the same time. But there is certain condition. He actually didn't mention that. Okay, what the certain condition? Okay, you can do the same experiment in your home. Okay, at the one hand you just take one ball, okay, and at the other hand you just take a piece of paper or just a simple paper. What is going to happen? You just then leave the two balls or the two objects at the certain time, at the same time. What is going to happen? What you are going to observe, practically what you are going to observe, or what any person is going to observe in their home, is that that ball is going to reach the ground first, but the paper will move like that. It is in dancing manner. Paper will go move downward in a dancing manner, but the ball will move directly to the ground. Why? Is Galileo was wrong? What do you think? No, Galileo was right, but there is certain thing that actually Galileo actually forget to mention. See, when we just leave certain object or two objects from a certain height, there is actually action of certain things or certain condition. That condition is nothing but what? Air pressure, okay, friction applied by the what? Atmosphere. Lots of things are actually there. Okay, so it will be there. So it will, what is going to happen? It will actually reduce the velocity of the objects. Okay, that ball is having higher mass compared to the paper. So that means what? That air pressure or the pressure is actually applied by the air is going to what? Small on that body, right? Simply that body with the different masses is going to have different inertia. Okay, and with different inertia going to be needed what? To remove that inertia, we are going to need different amount of forces. Okay, that paper is going to have less amount of inertia, and to reduce that inertia we're going to have less amount of force. And the ball, or tennis ball, right, it is having high amount of inertia compared to the paper. So to remove that inertia we have to apply high amount of force. As a whole it balances its condition, and if there is no external air conditions are there or air pressures are there, atmospheric pressures are there, what is going to happen? The two balls are going to reach the ground. Now you are just actually observing certain one experiment done by what? BBC World. What they did, first they actually condition at the room, certain room condition. What is happened? There is certain atmospheric pressures are there, air pressures are there. So they first did that one, they take feeder or one ball. So when they leave the two objects, they reach the ground at different times. But when they actually make a condition where there is no atmospheric pressure, no air pressures are there, it is also can say that they make the complete room vacuum. Vacuum means what? There is no medium. That means no air pressure, no air, actually friction applied by the air, nothing is there. So what is really going to happen? The two objects going to reach the ground at the same time. Okay, this is the one actually experiment done by what? BBC World. Again, just look here. It is the some things that is actually given by one experiment done by what? Astronauts. What they are actually saying, just listen very carefully. What they are actually saying.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct.
So what we have got? We have got that when there is no atmospheric pressure, no air conditions are there, two objects going to reach the ground what? At the same time. It means what we can say, that the objects, when they are going to reach the ground, that falling of that object is independent of its mass. That means what we can say, we have get the formula of small g as what? Gm by r square. Okay, now this is the mass of the earth. Mass of earth is the what? Radius of earth, right? And this is the what? UGC. That means universal gravitational constant. right? These all the things are actually constant. Okay, this is not related to with what? With that object. That means what you can say, this gravitational acceleration is independent of the mass of the object. If this is the ball, okay, so it is independent of z mass. That z is independent of the mass of the object, because here is no mention of this that mass of the object right now. Simply we can say that. So what you can say, when if you consider this concept, what is going to happen if it is a one big ball m1, it is a small ball m2. Since this gravitational acceleration is independent of the masses of the objects, only depends on the mass of the earth. So for the two objects, okay, for the two objects, when they will fall, for the two conditions, the mass of earth is going to be what? Constant. So it will be constant. Radius of the earth also constant, z is also constant. So this z will be constant on the both the two things. Simply. So what is going to happen? They are going to reach the ground at the same time. Same time. Right now, because they are having similar amount of z, that is similar amount of gravitational acceleration. Okay, when you just apply similar amount of acceleration to objects, they are going to get what? Reach the same position at the same time. Right? So this is the fact about that what? Free falling body. But whenever we actually discuss about the motion under the gravitational force, we have to consider three equations of motion. And the three equations of motion we get in what? The lesson or the chapter 8, that is motion. What are the equations? P equal to u plus at. One. Second is what? S equal to ut plus half of at square. And the third lesson was v square equal to u square plus twice of as. Okay, this 2 and this is 3. These three are the actually equations that we have actually got. Here, since we are discussing about the motion under gravitational force, and it is always going to apply when a certain object will fall from a certain height. Okay, that means the acceleration is going to be what? Z. So here that a will be replaced by the small z. So what will be the equations? Equations will be v equal to u plus zt, equation 1, and that s will be ut plus half of zt square, second, and the third one is v square equal to u square plus twice of gs. This is the third equation. Here second conditions are there. When we are discussing about the acceleration in the motion lesson, when there is retardation, that acceleration is going to be what? Negative. Similarly, this z will be negative when we actually throw something from a certain height to the upward direction. That means that z will be what? Acting backward or acting opposite to that of the what? Force. So then the z will be negative. When the object will fall from a certain height towards the gravitational force or in the same direction of the gravitational force, that g is going to be positive. Okay, that g is going to be positive. So we will actually get it when we will do some problems. When we have to solve some problems, we will actually get it. Again, we have to solve lots of problems using these three relations or three equations of motion. Okay, so these are the concepts of the what? Motion under gravitational force, or when there is some gravitational acceleration, we are going to get this kind of motions. Okay, now our next topic is going to be what? Mass. So when we are actually discussing about the lesson forces and laws of motion, we get one term, that is inertia. Right? What was inertia? Inertia is completely related with what? Mass. Right or wrong? It is completely related with mass. That means what you can say, mass is the measurement of inertia of a body. Okay, if certain object having high amount of mass, the inertia of that body is going to be high. Okay, so simply what we can say, mass is the inherent property or inbuilt property of an object. See, I have two hands. Okay, if there is no certain extra conditions are there, okay, I am going to have my hands are two. If I move to sun, if I move to what? Moon, if I move to any planets, my hands are going to be what? Two. That means what? It is my inherent property, or it is my inbuilt property that I am going to have only two hands. So similarly, the mass of a body or mass of an object is going to be what? Constant thing. It is not going to change anywhere. So this is the main thing about the mass, but there is certain condition. Okay, with the mass, okay, with mass, if we add something or multiply something extra condition or extra quantity, that quantity what we are going to get as the result is not going to be constant. You will get, and that thing is known as what? Weight. Now what is weight? we have to actually discuss it. What is weight? Weight is nothing but a force applied by the earth on a certain object. Weight is nothing but what? Force applied by our earth on a certain object. We know that whenever we actually lift something, it is going to move directly towards the what? Ground, and that force is what? Perpendicular direction to the what? Ground, right? See, I have to clear one concept of you, that what I told, if there is a certain ball here, it is moving in this direction, but the gravitational force that is actually applied here or is in this direction, it is perpendicular to the ground, not in this direction. Okay, you should be very much clear about that. Though it is moving in an inclined path, the gravitational force acting on body is in this direction. Okay, that means what you can say, that body is getting a what? Effect of, or feel a certain gravitational force. That force is going to be what? Perpendicular to the ground. We actually got it, that gravitational force is the perpendicular force that is actually applied on a certain body. That force is actually gives us the weight. Okay, and whenever we have to discuss the force, it is the what? Product of the two quantities. One is the mass, that is this mass, and it is represented by what? M, and the acceleration. Here, whenever we have to discuss the relation gravitation, the acceleration is going to be what? Acceleration due to gravity is actually represented by what? Z. And product of these two things is going to give us what? Force. Because we know that F equal to what? Ma. Here A is replaced by Z. So this is also give us what? Force. That force is also known as what? Gravitational force due to the acceleration due to gravity. Right? This force applied by the earth on a certain body is basically known as what? Weight. So what we can say, that weight of the body is nothing but mass into acceleration. Simply mc. Okay, W is nothing but, W is for weight, which is also known as what? Mg. Right? Mass is the inbuilt property. Z is going to change. Right? So as a whole, weight we are going to get. Again, what is the unit of the weight? If you ask me, sir, what is the unit of the weight? See, weight is what we got. Weight is nothing but what? Force. The unit of force is what? Newton. So the SI unit of force is Newton, since it's also a force. Okay, and the force applied by the earth on that body is also known as weight. So as a whole, what you can say, the weight unit is nothing but what? Newton. Again, when we are discussing about that free falling of a body, we said that whenever we will actually discuss certain falling of a body or certain object in the ground of the earth or near the ground of the earth, we will consider that G is constant except equator and pole. Okay, so this is the fact. So what is actually going to happen, that Z is going to be constant. Z is constant in earth surface. Okay, I will consider that earth surface, not only in earth, because in earth there is equator and pole too, right? So we consider earth only, earth surface. Okay, so if the Z is constant, what you can write, weight is proportional to M. Right or wrong, we can say that weight is directly proportional to M. That means M is what? Mass. Mass is constant, so weight is going to be constant too if it is directly proportional to M. So what you can say from this thing, that is W is proportional to M, that how mass will change, weight is also changed according to that. If your mass is 60 kg, weight is also going to be 60 kg. If your mass becomes 70 kg, your weight is also become 70 kg, because it is independent of what? Small z. But the fact is, it will also depend on the value of Z. Okay, because at the equator and pole we have got that Z is also changes. So in that case, what is going to happen? W or weight is also going to change. So now we will check that what will be the weight of an object in the moon. Okay, and how it is going to vary the weight in the moon. What is going to actually happen? We will check it. Okay, now we have to actually discuss what is going to be the weight of an object at the moon. But before that, what we have actually got, we have to actually understand it, that the weight of an object is nothing but what? The force applied by the earth surface or earth on a certain object. So whenever we have to discuss the weight of an object in the moon, so what we can say, that whenever we have to discuss, or when we will discuss the weight of an object at the moon, what we can say, that the surface of the moon or moon applies the amount of force on the body, that force is going to be the weight of that object or that body in the moon. So for that we have to consider that Wm Okay, Wm is the what? Weight of the body. Weight of the body in moon, right? And m is the mass of the body. Since mass is constant, so we don't need to write in moon or in earth. Okay, mass is constant everywhere. Okay, and Rm is a what? Radius of moon, right? You got it? So Z is known as UGC, that means universal gravitational constant. So for this, what you can write, F equal to Z mm, that is the mass of the moon, into m by Rm square. And we know that force, that is the gravitational force applied by the moon surface, is going to be the what? Weight of the body. So what is going to be there? Wm is equal to Z mm or m suffix m into m by Rm square. One condition, right? So similarly, if we apply the same thing in earth, okay, or if you try to find the mass of the body, sorry, not mass, if we try to find the weight of the object in the earth, what you can write? We is equal to Z me into m by re square. Question number 2. Here me is the mass of the earth, we is the weight of the object in the earth or on earth, or re is the radius of the earth, right? So yeah, these are the things. First, let me erase this thing. There is a chart in your book that where the mass of the earth, mass of the moon, okay, radius of the earth and radius of the moon is actually given. Okay, so from that chart, what you can write? Mass of the moon is nothing but 7.36 into 10 to the power 22 kg. We know the mass of the earth as what? 6 into 10 to the power 24 kg. Again, radius of the moon is known as what? 1.73 into 10 to the power what? 6 meter. And R of E is nothing but what? 6.4 into 10 to the power 6 meter. Okay, we get this. Now, when we will actually put all these values in these equations, what we are going to get? Here, Wm will be what? Z will be constant. Mass of the moon, we have got that 7.36 into 10 to the power 22, right? And m will be remain as m because m is constant. And what we have got Rm as 1.73 into 10 to the power 6 whole square. That is nothing but what? Meter square. Okay. Again, what is going to be the We here? You can also write Z is going to be constant into what is the mass of the earth? It is 6 into 10 to the power 24 into m. M is constant. Again, what is the radius? 6.4 into 10 to the power 6 meter square. Okay. So if we have to find out the amount by which it actually varies, we have to do what? We have to give them number 3 and 4. We have to divide 3 by 4. So what we are going to get, just wait for a minute. Okay. So if we do that 3 by 4, so what we are going to get? Wm by We. Right. So what we are going to get by that? We are going to get that Z will cancel out, mm will be cancelled out. So what is going to be there? So what will be there? 7.36 into 10 to the power 22 by what? 1.73 into 10 to the power 6 whole square. Okay. And what we are going to get here? 6 into 10 to the power 24 by 6.4 into 10 to the power 6 whole square. Right. So again, all the units are same here, so it will be cancelled out, right? So if you solve the whole part, you are going to get 2.431 into 10 to the power 10, right? You will just cancel out the units, and in D, if you solve this portion, you are going to get how much? You are going to get 1.474 into 10 to the power 10. Okay. So if you further solve this whole thing, 10 to the power 10 to the power will cancel, 2.431 will be there and 1.474 will be there. And if you solve this, you are going to get 0.165. Again, it is almost equal to 1 by 6. right? So what we have got, that Wm by We is almost equal to 1 by 6, right? So what you can say from here, that Wm is equal to 1 by 6 of the We. So what you can say from here, that mass of the object in moon, okay, is 1 by 6 times the mass of the object in the earth. That means what you can say, it is quite small, okay. That means what you can say, if certain weight, okay, consider me as a object, okay, I have weight 70 kilos, okay, 70 kg, okay, my weight is 70 kg in what? Moon only, okay, only in moon. In earth, okay, it is going to 6 times more than this. That means 70 into 6 kg. So what is going to be my weight in this earth? 420 kg. So this is the fact. So what you can say, that mass of the object in moon is 1 by 6 times of the mass of the object in the earth. This is the fact what we can actually get from this concept, that is weight of an object in the moon. We have got it. It is because if somebody asks you why there is a variation, because we have got that z is also what? Z m by r square. Or what we have get, that the weight is nothing but what? Applied force by the earth, and that force is given by what? F equal to mg. And this is known as what? W equal to what you can say? Mg. If z varies, weight will also vary. Mass is the constant thing, right? In z value in earth is 9.8. Whenever you will try to calculate the value of the z, you are going to get different value. Or simply what you can say, z is going to be the less compared to 9.8. So your weight is going to be different, or your weight is going to what? Basically less, because 1/6 times is going to be less. Or simply what you can say, 1 by 6 of 9.8 is going to be the z, because mass is the constant thing, okay. That means z value in moon is almost going to be what? 1.67, almost it will be like that, meter per second square. Because why? How we can say that? How I can say that? Because weight is defined by mass into z, because mass is constant in both moon and earth. So what is the variable thing here? Z, okay. If it is like that, if mass is the constant thing, so I can write, and what is the z value here? Right now, I can actually just showing this for your convenience. So the value of z will almost be like that, 1.67 almost meter per second square. I'm just giving an approximate value, not an accurate value, okay. So this is the fact about the concept of the weight of an object at the moon, how it is actually varies from the object weight in the earth, okay. This is the concept of this thing. Now our next topic is going to be what? Thrust and pressure. Okay, to understand this thrust and pressure, or the concept of thrust and pressure, we have to actually discuss some examples, okay. I hope you all have knife in your home, or some certain sharp objects here in your home. If you notice that, what you will observe is that one part or one side of that sharp object is quite sharp. Why? First question. Secondly, whenever you just observe those big trucks, you will observe that their tires are quite wide, okay. If you have ever been to deserts, like in Rajasthan you have deserts, right? So this is our pride of our country, that in Rajasthan we have what? Thar desert, right? So it is known as Thar. So what is happening? If you try to run in the desert, what is going to happen? You will not be able to run in the desert, because your feet is going to get inside in the sand. But in the same situation, that a camel run faster in the desert. Why? This is one question, right? So all these questions is actually possible to explain with the help of this concept, that is thrust and pressure. Now what is thrust? Thrust is the force also. It is also a kind of force, but that force have to be applied perpendicular to the surface, okay. If this is the surface, again, okay, again we have to actually apply a force. We have to apply the force in this direction. That is, this force is perpendicular to this surface, so this is going to be the what? Thrust. Now what is pressure? pressure is nothing but the variation of the thrust or variation of the force per unit area. So what you can say, pressure is the force per unit area. Okay, right? So this is the main concept about the pressure and thrust. To understand this concept of pressure and thrust, we have to consider one example. We have to actually consider one example or one condition. What is that condition? When you will just try to stand in the desert, what is going to happen? Okay, your feet is going to get inside then the desert. So if this is the desert, okay, if you are like here standing like this, your half portion of your feet will go inside in the desert because you are just applying a force perpendicular to the ground. And what is that force? Is nothing but what? Your weight. Weight is nothing but what? Mg, right? This is your weight, and your weight is going to act as a force perpendicular to the ground. But when you just lie down in the desert, what is going to happen? Certain amount of your body is going to get inside, but it will be comparatively less to this condition when you are just standing on the ground of the desert. Because why? Here what is happened? The exposed part of your body or the exposed area of your body is high now. Only first condition, only this amount of area is exposed to the ground. But now whole body or whole area of your body now exposed to the ground. But the similar thing is going to be the force. Here also your weight is mg or w1, and again here your weight is going to be w1. That means in both the cases forces are same, but the fact is the exposed area of your body, here the exposed area of the body increases. Okay, when we vary the weight with the area, that means if it is a force, and if we actually find the rate of that force or find the force with the help of the area or along with the area, we get one more new term that is known as pressure. That means what you can say, pressure is nothing but the force per unit area, because from every portion of the body having a applied force, right? W1, 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 like that. So what is going to be happen? The total amount of force that we are going to get is going to be reduced to the ground. And that force have a new term known as what? Pressure. Simply what you can say, that is nothing but in this case, though since it was the what? Perpendicular force, that force is known as what? Thrust. Okay. When we actually vary the thrust with the help of the area, or when it is changes per unit area, we will get what? Pressure. So what you can write? Pressure as thrust per area. Right or wrong? Right. Again, we have got the concept of the pressure and thrust. So if somebody asks you, or if you ask me, so what is the unit of the thrust and what is the unit of the pressure? Thrust is also a force, right? So each unit is be what? Newton. As a SI unit, and area, it is completely related with what? Length. So SI unit of the length is what? Meter. So it is area. So area will be what? Meter square. So as a whole, unit of the pressure is going to be what? Newton per meter square. And it is known as what? PA. PA for Pascal. Or that Pascal came from the name of the scientist that is known as Blaise Pascal. Okay. So that Pascal was given after his name. Okay. This is the main concept about the what? Thrust and area. And because of the concept of this pressure and thrust, or how pressure varies with area, there are certain objects which makes as small. See, consider that what you have got from here, that pressure is equal to F by A. That means what you can say, pressure is inversely proportional to the area. As area decreases, pressure is going to increase. As area increases, pressure is going to decrease. So whenever we have to consider a nail, here at the tip of the nail, it is having less area. So the pressure going to be exerted by this nail is going to be high. Okay. Whenever you just observe a building, what is actually, if it is the ground, building is made in wide area. So that building cannot apply high amount of pressure in the ground because it is in high amount of area. So with area, pressure is going to reduce. So the buildings are made in a wide area. Okay, if you make a building like that, so what is going to happen? Your building is going to get apply high amount of pressure in the ground. So there is a possibility that the building will get collapsed. Okay, due to the pressure applied in the ground. Okay, this is the fact. That's why we always make buildings in a wide area. This is the fact of that pressure and thrust. Or this is the whole concept about that thrust and pressure. See, till now we have to discuss pressure applied by the object in normal surrounding, right? So there is also one concept of the pressure of the fluids, or pressure in the fluids. So what it actually means, or what it actually try to explain to us, whenever we try to fill a bucket, okay, consider a bucket, okay, which is closed from every sides, okay, and throw a pipe or throw a hole, you are just continuously entering water. So at a certain level or at a certain time, what is going to happen? Okay, that bucket is going to explode from every portion or from every direction, because from there, what you can say? From there we can say that those fluid or that water in that bucket is continuously applying certain amount of pressure in all directions of the bucket, right? If it is a bucket closed from every direction, if you have filled up water fully, what is going to be? There will be force in every direction, right? So at a certain level, what is going to happen? That bucket is going to crack like this, okay, and water will be here and there. And that happened because of that, or from this experiment, what we can say, that there is going to be the pressure applied by the fluid in the surface or in the surrounding or in the walls of the bucket. And this also explained that not only we are going to get the pressure in open or surrounding, okay, or certain objects or certain matter, also fluid have certain amount of pressure in its surrounding walls, okay, where it is actually kept. So again, this pressure concept in fluids leads us to one main important fact or important concept, that is known as what? Buoyancy. That is B-U-O-Y-A-N-C-Y, buoyancy. Now what is buoyancy? Okay, before that we have to actually consider certain conditions. See, whenever you just try to throw a small nail, okay, what is going to happen? The nail is going to sink, but a big ship, okay, which is quite big in size, is going to float in the what? Water. Again, whenever you just try to walk, whenever you just try to swim, by the way, I don't know how to swim, okay, so this experiment or these things that actually I'm going to tell you is I have to actually ask certain person who know how to swim, okay. When you actually swim, what is going to happen? You are going to feel yourself as a lighted one. It means you are going to feel yourself as light. It means you are going to feel that you are having some sort of less weight. Okay, again, you can consider one more example. It is actually done by me too. Again, I've experienced it. Whenever you just try to pull water from a well, whenever the bucket is inside that water, it feels lightweight. But once it comes out of the water, what actually it feels more heavy. What are the reasons behind this? You can explain all these things with the help of this concept, buoyancy. Okay, to understand the concept of the buoyancy very well, we can consider one example. First, consider one bucket which is filled with water. Again, consider one empty bottle which is keep tight through its mouth, okay, so that extra things cannot enter that bottle or water cannot actually enter that bottle, okay. So whenever you just try to push that bottle inside that water, okay, you will feel that bottle is actually having some amount of force from the backward direction, okay. That force you are going to apply from the outside direction is going to be countered by the applied force by the water, and that force applied by the water is going to be in the backward direction or in the opposite direction to your force, that is you are applying externally, okay. If you are applying force on the bottle like that in the water, okay, there will also be an existence of a force applied by the water in this direction, okay. That force applied by the water on that bottle from the opposite direction is known as what? Upthrust. Upthrust. And thrust we have got. What is thrust? This is a perpendicular force applied to the ground or applied to the surface. Again, this direction of the force applied by the water is also perpendicular to the surface of the or the lower surface of the bottle. Second, since it is applying in the upward direction, so it is known as what? Upthrust. Or simply we can say that your external force is down thrust or the downward force, okay. You are actually applying from outside direction, okay. So again, whenever you will move to a certain height like that, that means what you can say, whenever you will just move more inside the water, you are going to get more force applied by the water. That means you are going to get more upthrust, or you are going to get more opposite force, or you are going to feel more opposite force in this bottle. But once you reach the ground here, now you are not going to feel any force because you are not almost at the ground, okay. See, whenever you drop certain stone from a certain height, once it reaches the ground, is this going to get any kind of force? No, it is basically a lowest potential or the lowest level, so it is not going to feel any kind of forces there. right? Similar cases also here. Okay, this is the concept. What about the upthrust? But the fact is, we know that in every object in this whole universe there is the application of what? Gravitational force. So if you just leave the bottle in this condition, it should be what? It should be remain as like that. But what will happen once you leave the bottle from this position, okay, or you just remove your external force from this condition, what is going to be? The bottle will start floating in the outer surface, right? So what you can say, that gravitational force will be there, okay? That's why it is actually keep in touch with the water, but that gravitational force is not that strong to counter that upward thrust. So this is the concept about the what? Buoyancy. Okay, whenever we just apply that external force have to be at least equal to the difference of the upthrust and the weight of the body. That means what I'm saying, if the upward force applied by the water is that Fu, okay, and if the weight of the bottle is W, okay, the difference between these two things is going to give us the value that how much force is actually absent whenever that bottle to get down. Okay, so whenever we have to apply external force, that external force, that is Fe, should be equal to this force, that is difference between the upthrust force and the weight of the body. Okay, then the bottle will start moving down in the water. Once that external force becomes greater compared to this difference, then it will give more inside in the water. Okay, if you just leave this bottle or leave this external force, what is going to happen? The bottle will again move upward. This is the concept about the what? Upthrust or the buoyancy, or the pressure applied by the what? Water. Again, with the help of this concept of the buoyancy, you can actually say why a certain object is going to sink or is going to float. See, again, I have told you about one thing, that whenever you just throw a small nail in the water, what is actually going to happen? It will get sink in the water. But if you throw a cork, okay, which is kind of made of woods, okay, if you just throw a cork in the water, what is going to happen? It will going to float in the water, right? What is the reason? It is mainly because of the density. The objects which is having low density compared to the water, that objects with low density is going to float in the water, okay, and the objects which is having high amount of density compared to the water is going to sink. That nail is having high amount of density compared to the cork, that's why that nail is going to sink in the what? Water. Again, that cork is having low amount of density, that's why it is going to float in the water. So similarly, what we can say, that upward force applied by the water in the cork is high, okay, so that it is actually floating, right? Again, the upward force applied by the water in the nail is less, that's why it is going to sink. That means if I consider this is a bucket, okay, till now water is here, okay. If it is the cork, right, it will have some amount of force downside, okay, consider this is Fd, okay, and water will apply also a force in the opposite direction, that is known as what? Fu. In the case of the cork, Fd is very less than Fu, so it is going to be float in the water, right? And it is because of the density too, okay, because water is having high amount of density compared to the what? Cork. Similarly, when you just try to dip a nail in the water, what is going to happen? It will be directly moved to the ground, or it will get sink, because here the downward force is higher compared to the what? Downward force is higher compared to the upward force. Okay, this is the concept about the buoyancy. Okay, how that buoyancy actually works. Buoyancy is nothing but what? Water having some amount of pressure on that object which is going to be down. Okay, if that buoyancy increases, the upward force is going to increase. So then if that upward force of that buoyant force or that buoyancy is higher compared to the downward force applied by the object, then that object is going to float in the water. In other cases, if that buoyancy is less compared to the downward force applied by the object, then it is going to sink. But one scientist or one physicist named as Archimedes, Okay, you have heard about that name, right? Give one direction to this concept of the buoyancy, and with the help of that direction we can actually explain, though this nail gets sink in the water, which is also made up of iron, a big ship which is also made up of iron doesn't get sink in the water. Okay, why actually happens? What actually Archimedes said? He said when a body is actually immersed in water partially or fully, okay, the upward force that body is going to feel, okay, is the amount of the water is displaced by the object. Okay, just let me explain very well. Okay, you will understand it, and this is one more important concept that you are going to get. Okay, so I am gonna draw one big bucket now. Okay, and water is filled till here. Okay, water is filled till here. So whenever you just drop a small nail in the water, the amount of water that is going to be displaced by this nail is what? Quite less. So what I can say, if the amount of displaced water is less, so that upward force is going to get applied on this nail is going to be what? Less. So that means upward thrust or upward force is going to be less compared to the what? Downward force. That's why it is going to sink. But if you just consider a big ship, right? Big ship, due to its weight, it is going to what? Displace high amount of water. Okay, since that water displacement is directly proportional to the upward force, so what you can say, the upward force is what is actually applied here or is applying here in this ship is going to be high compared to the downward force. So that's why what you can say in that case of the ship, that Fd is very much less compared to the upward force. That's why you are just able to see that those ship actually floating in the water. Okay, it's because of the displacement of the water is high in case of this ship. Okay, because it is having high amount of area, right, or high amount of volume, right? With high amount of volume, we can also say that if high amount of volume is there, low density is also there. Okay, we also know that with the low density compared to the water, it is going to also float in the water, right? So what you can say here, that in this case the displaced water is high. So along with that, what you can say, the upward force is also high. It was actually proved by Archimedes. He said that the upward force when body is actually immersed in water partially or fully is equal to the water displaced by the body. So here water displacement by the ship is high compared to this small nail, right? Since water displacement is high, upward force on the body or that ship is high, so it is going to float in the water. This is the concept about the Archimedes principle. With the help of this Archimedes principle, or now when those engineers have to build a ship or submarine, they have to follow this Archimedes principle. Okay, when you will go to the higher classes or in maybe higher secondary or class 11 and 12, you are going to get a what? Fluid dynamics. Okay, in that lesson you are going to get to study whole concept of this Archimedes principle in a brief manner, but till now you just have to understand this concept. If high amount of water displacement is there, so what you can say, the upward thrust or upward force will be higher. If low amount of water displacement is there, so what is going to be there? Low amount of upward force is going to be there. So this is the concept of the Archimedes principle. So we have actually understood the concept of the Archimedes principle or the buoyancy. Okay, so when we are discussing about the term buoyancy, then we discuss the term of the what? Density. Now what is density? I told you that density is nothing but what? Mass per unit volume, right? If density is d, it is right mass per unit volume, right? Density of the object is also its inherent property or its characteristic property. Okay, so density of gold is what? 19300 kg per meter cube. Again, the unit of density is what? Kg per meter cube, because mass having unit of kg and volume having unit of meter cube. So the unit of density is going to be what? Kg per meter cube. And the density of it is gold, and density of water is how much? 1000 kg per meter cube. So what you can say? With the help of density, we can actually say its purity, right? So this is the concept of the density. Whenever or when we try to find the density in comparison with the water is known as what? Relative density. So our next topic is about what? Relative density. Okay, So what is the relative density? It is the ratio of the density of the object, okay, density of the object or the certain substance to the density of the water. Okay, always remember one thing, if there is certain word relative, okay, the relative word always mean comparison of a certain object with the other. Here we are just comparing the object density with the water. So this is the concept of the relative density. Again, since it is also density, it is also density, so all the units of the density is going to cancel out, so the relative density is going to have no unit. There is a question that what is the unit of the density, so you have to write that density is having no unit because all the densities unit is going to be cancelled out, okay, because the numerator is also density, denominator is also density, so the kg per meter cube, kg per meter cube is going to cancel. Again, this relative density is going to be the vary with this object, because all objects having what, no similar density, they all objects having different number of density, but density of water is same, but the numerator, that is density of the object, is going to vary for every object, with every object, right? So as the objects vary, density of the object also vary, so along with that the relative density is also going to vary. So this is the concept of your relative density, and in this concept of relative density our lesson gravitation is going to end. Okay, in the next video we will basically discuss problems regarding this lesson. Lots of numerical problems are also there using that equations of motion, right? That gravitational force law, that is right, g mm by r square. We have to do lots of problems from this lesson too. Forces and laws of motion and lesson motion. So we are having lots of problems from this lesson too. Okay, we have made lots of journey, right? Till now we have actually almost completed 3 lessons. So it is my whole request to you, or my kind request to you, that do not skip my videos, because I just cover lots of conceptual things in my video. I'm not like the other YouTubers, okay? I just cover all the things in a brief manner. That's why I make more parts. Almost 2 parts are there in every video, not a single part. So this is the fact. That's why you shouldn't skip my videos. Okay, it's my kind request to you, or my kind advice to you, because see what is going to happen if you just skip my videos. What is going to happen? You are going to get harmed by yourself. I'm not going to get, or I'm not going to lose anything. Okay, you will lose, because you will lose the concept. Once you move to the higher classes like higher secondary, if you have clear concept, then you are not going to get any kind of difficulty. Otherwise, if you are having no concept regarding this concept, that is what is the concept regarding the buoyancy, Archimedes principle, you are going to get tough. Once you now clear your concept right now in right condition, you're going to get no difficulty. Okay, now it is time to announce the winner's name of that last quiz competition. Again, today I will also consider one quiz competition too. Okay. Okay, by the way, this is our last quiz question. That what this question actually is saying, that a bullet of mass A and velocity B, right, is fired into a wooden block of mass C. Okay, and if the bullet gets embedded in the wooden block, then the magnitude of the velocity of the whole system just after collision will be how much? That means a bullet is actually given whose mass is A and it is having velocity B. Okay, it then just hit a wooden block which is having mass C. So now we have to actually find out the velocity of the whole system when the bullet is inside that wooden block. Okay, what will be the velocity? So the solution will be like that. See, we have found that the bullet is having a velocity B and having mass A, and wooden block having mass C, right? And it is, since it is at rest, it is going to have velocity 0. So again, that if we consider that capital V is the velocity of the whole system, right, after the collision. Simple fact. Now, what is the moment of actually conservation momentum says that momentum before collision is equal to the momentum after collision, right? So mass A, velocity B, mass C, velocity 0 because it is at rest. Then combined velocity is how much? Capital V. So if you further simplify this, you're going to get capital V is equal to AB by A plus C, right? This is the complete answer. So now I will check who have given me the correct answer. Okay. So first answer was actually given by Anurdeka. After that, given by Analip Kashyap, then Diptangsu Imperio. After that, Amanchita Rahman. Again, Rakibul Hussain. After that, Bandita Saikia give the correct answer. But among all these answers, one of the answer I actually found quite interesting and quite good one. That person or that boy actually did lots of hard work in giving that answer. And his name is Analip Kashyap. He write down the answer quite properly, like he is writing in the exam. That's how he actually write in this quiz competition too. because what I can say from this answer that he actually applied his amount of hard work while actually just writing this question, because in comment section it is not that much possible to write lots of things, but he actually tried, and I just want to appreciate your effort, Analip. Good one. So keep trying like that. And okay, by the way, we will just now move towards our next quiz question, or today's quiz question. Okay, this is the today's quiz question. Here actually I have given two questions. Those students who will give me the correctly two answers of these two questions, they will be actually considered as the winners. Okay, so yeah, what is the first question is saying? What is the value of the universal gravitational constant on moon if in Earth it is g? Options are given, right? What is the question 2 is actually given? What is the weight of an object on the surface of the Earth? Okay, 1/6 of the that of the Earth, 1/6 of that of the moon, 1/6 of the that of the Earth core, and 1/6 of that of the moon. So these are the actually questions that is actually given. Just pause the video here, write down the questions in your copy, then solve it and give me the correct answer. But before that, if you want to give me the answers correctly, just watch the two videos that I actually uploaded for this lesson, then try to answer it. Then you will be able to give like answers like Analip that actually given. So try like that. Give me your this 55 to 60 minutes or 1 hour of your time and watch the videos and give me the correct answer. Okay. So we are now at the end of this lesson or end of this video too. If you have liked the video for whatsoever reason, just subscribe to my channel and just like the video if my way of teaching is good. Okay, or if you're just liking it, okay, just hit the like button, then I will get the encouragement. Okay, so along with that, I will meet you in the next video. Till then, stay safe, stay healthy, and watch my videos properly. Don't skip it. Okay, if you do not skip it, you are going to get lots of knowledge. Okay, so till then, bye bye.